How does the GSE CO₂ controller work? 1. Installation of the CO₂ controller. Before installing the controller, use the supplied screws to mount the brackets onto the controller, and secure it to your wall. Ensure that the controller is installed in a safe, and well-ventilated area. For safety reasons, it is strongly recommended to mount it on a non-flammable surface, such as brick or concrete. Never mount it on wood, plastic, cardboard, or similar materials. Avoid placing the controller in small, unventilated rooms, or cabinets, as improper installation can lead to overheating. For AC fans, plug the intake fan into the left socket, and the exhaust fan into the right socket. For AC fans, connect the intake fan to the bottom left port, and the exhaust fan to the bottom right port. For lights, connect to the center port. Other devices, connect additional equipment such as a pump, heater, cooler, humidifier, dehumidifier, or CO₂ valve, into any available power socket. Place the CO₂ sensor, or the temperature humidity light sensor, in the area you wish to monitor. To ensure accurate readings, avoid direct exposure to heat sources, or light streams. The sensor should be positioned in a well-ventilated area, where it can measure ambient air effectively. The second waterproof temperature sensor can be placed in various locations, such as in the air, inside a water tank, or above a heating mat, depending on your measurement needs. Powering the controller. The power supply method depends on the model. If your controller has 2 power cables, each cable should be connected to separate power circuits, 16A or 13A household plugs, depending on the country. If you have a 3-phase plug, connect it to the corresponding C16A socket. Once powered on, the screen will light up, and after a short startup sequence, the controller will begin operating. The light sensor adjusts the screen background automatically. White background during the daytime. Black background at night. Additional light sensor settings can be adjusted in the photo sensor submenu. The main screen is divided into 3 sections. The first section displays CO₂, humidity, and temperature values from air gas sensor 1. The temperature readings from liquid sensor 2. Day counter. Time. CO₂ sequence bar. And countdown timer. Use the rotary push knob to navigate. Turn the knob clockwise to access the second section. It displays all current controller values, including exhaust fan speed, intake fan speed, current grow light intensity, the status of the 4 output channels, on-off, automatic, or manual mode. Turn the knob clockwise again to access the third section. It displays the minimum and maximum recorded values of all sensors. To return to the first section of the main screen, continue turning the knob clockwise. 2. Fan controller functions. Press the knob once to enter the submenu. At the top of the screen, you will see the submenu navigation bar. The deeper you navigate into the settings, the more steps will appear. Turn the knob clockwise until you reach the fan controller menu. The currently selected menu will be highlighted with a larger icon. Press the knob once to select the fan controller menu. Press the knob again to enter the temperature settings. Press once more to access the day temperature setting. At this stage, 2 sidebars will start blinking, indicating that the value can be modified. Turn the knob clockwise to increase the value. Turn the knob counterclockwise to decrease the value. Press the knob again to save the setting and return to the selection screen. Turn the knob clockwise to navigate to the night temperature setting, and repeat the same adjustment process. Continue turning the knob clockwise, until you reach the hysteresis setting. The hysteresis defines the range between the minimum and maximum temperature, before the fan speed fully adjusts. To return to the fan settings menu, navigate to the fan icon at the top menu bar, and press the knob. Turn the knob clockwise to navigate to the humidity settings. Repeat the same process as for the temperature settings to adjust humidity levels. Between temperature and humidity, the stronger signal always determines the fan operation. As long as the measured temperature at the probe remains below 24 degrees Celsius, the controller keeps the fan running at 20% speed, based on the minimum speed setting. When the temperature rises above 24 degrees, the fan speed increases proportionally, over the next 2 degrees hysteresis setting, reaching 100% fan speed, at 26 degrees. As the fan speed increases, more fresh and cool air circulates in the room, lowering the temperature. Once the temperature decreases, the fans slow down accordingly. This process is called automatic airflow balancing based on temperature. The same principle applies to humidity. If the measured humidity at the probe is below 60% relative humidity, the controller keeps the fan running at 20% speed. When humidity exceeds 60%, the fan speed increases proportionally over the next 10% humidity hysteresis setting, reaching 100% speed, at 70% relative humidity. As fan speed increases, more fresh and dry air circulates in the room, reducing humidity. Once the humidity drops, the fans slow down accordingly. This process is called automatic airflow balancing based on humidity. Return to the fan setting, and choose Maximum and Minimum Speed Settings menu. The left side of the screen controls the minimum speed setting. The right side controls the maximum speed setting. The first row represents the daytime settings. The second row represents the nighttime settings. On the third row, you can adjust the intake fan behavior. When set to on, the intake fan will not stop even when the temperature and humidity are below the set values. When set to off, the intake fan will stop when not needed, while the exhaust fan will continue running at its minimum speed, to maintain negative pressure in the room. On the right side, you can set the minimum temperature at which the exhaust fan should switch off. Return to the fan setting and choose Negative Pressure Settings menu. The negative pressure reduces the speed of the intake fan during controller regulation. It operates synchronously with the exhaust fan. We set a negative pressure of -50%, meaning the intake fan runs at 50% of the exhaust fan's speed. For example, if the exhaust fan runs at 100%, the intake fan operates at 50% speed. If the exhaust fan runs at 80%, the intake fan operates at 40% speed. And so on. Once the temperature and humidity drop below their set values, the intake fan will either stop or run at minimum speed, according to this given setting, or the exhaust fan will stop if the temperature drops below the minimum value. This setup ensures a consistent negative pressure, preventing unwanted air leaks and maintaining proper airflow regulation. 3. The CO₂ function. Return to the sub-menu and select the CO₂ settings. The CO₂ function operates only during the daytime and only if there is a sufficient CO₂ supply in the room. If the CO₂ bottle is empty, an alert will be triggered, and the system will revert to the fan settings. Use the switch on the lower left side to activate or deactivate the CO₂ function. To enable CO₂ dosing, a CO₂ sensor must be connected. Go to the first CO₂ setting menu and choose the desired CO₂ level for the room. Then, navigate to the CO₂ hysteresis setting. For example, if you set the CO₂ level to 2000 parts per million, and the hysteresis to -200 parts per million, the controller will dose CO₂ up to 2000 parts per million, and redose if the level drops below 1800 parts per million. Return to the CO₂ settings and set the dispersal time. This determines how long the air circulation fans will run after dosing, to evenly distribute the CO₂. Larger rooms require longer dispersal times, to ensure accurate CO₂ readings. It is recommended to position the CO₂ hose directly behind an air circulation fan, to optimize distribution. Next, configure the number of redosing attempts, How many attempts before triggering the CO₂ bottle is empty alert. For further details, refer to the CO₂ room settings. Go to the Start Fan and Stop CO₂ menu. There are 3 conditions that should not be exceeded during CO₂ dosing. These conditions determine the highest threshold for starting fan operation. Set a threshold, and activate or deactivate the condition, using the button on the right. If any of these maximum conditions are reached: temperature, too high. Humidity, too high. Countdown timer, CO₂ time elapsed. The CO₂ dosing stops, and the fan starts running again. Go to the Start CO₂ and Stop Fan menu. Here, you will find the same 3 conditions that must be met for CO₂ dosing to begin. These conditions determine the lowest threshold for stopping fan operation. Temperature. Set a temperature threshold, and activate or deactivate the condition, using the button on the right. Humidity. Set a humidity threshold, and activate or deactivate the condition. Countdown timer. Define a fan time before CO₂ dosing begins. All of the activated conditions must be achieved to stop the fan and start the CO₂ dosing. If you are using an air conditioner, which is recommended for cooling and dehumidifying during CO₂ dosing, the set maximum limits may not be reached, allowing CO₂ to remain in the room during the CO₂ period. Navigate to the fan stop time setting. This determines how long the system waits before the fan engine comes to a complete stop. Larger fans require longer stop times. Go to CO₂ room settings, and enter the room volume, in cubic meter. Next, set the gas flow rate, as adjusted on your pressure gauge. Keep in mind, that these values may not be highly precise. Return to the CO₂ settings and select minimum fan speed setting. Here you can set a minimum speed to the exhaust fan, if you want the fan to operate during the CO₂ function, even while CO₂ is being added to the room. Once these values are set, and CO₂ dosing begins, the goal is to inject the right amount of CO₂. Enough to avoid frequent redosing, but not so much that it exceeds the set CO₂ level. Fine-tune the pressure gauge flow rate, and the CO₂ controller gas flow rate accordingly. Note that the minimum speed setting on the exhaust fan will also affect this balance. 4. The light controller functions. Return to the submenu and go to the light settings. The first button allows you to activate the light settings, using the 0 to 10 volts, or PWM output signal. Go to the time settings and set the on and off times for your lights. For example, we set on time of your cycle to 8 o'clock. And off time to 20 o'clock. Your lamps will start at 8 o'clock. And stop at 20 o'clock. Navigate to the light controller dimming menu. At the top, you will see the CO₂ temperature settings, displayed as a reference. The dimming function allows you to gradually reduce light intensity, if the room temperature becomes too high. Set the start dimming temperature, which is the temperature at which dimming should begin. For example, if set to 27 degrees, the lights will start dimming at this point. Set the end dimming temperature, which is the temperature at which dimming should reach its lowest level. For example, if set to 30 degrees, the lights will dim progressively between 27 degrees and 30 degrees, from maximum to minimum brightness. Set the maximum dimming value in % of the lamps. The level of the lamp power should never exceed. Set the minimum dimming value in %, which determines the lowest point at which dimming should occur. Depending on your lamp model, this value may vary. Even at the lowest dimming level, the lights will remain operational. Set the shutdown temperature value, which is the maximum temperature limit. If exceeded, the lights will turn off completely. Set the restart temperature value, to switch the lamps back on. Preferably, this value should be higher than the end dimming temperature. Go to the sunset and sunrise menu, and set the transition times. Enter the sunrise time in minutes, for example, 10 minutes, and activate the function. If the lights are scheduled to turn on at 8 o'clock, they will start at the minimum dimming level, and gradually increase in brightness, until reaching maximum dimming at 8:10. Enter the sunset time in minutes, for example, 10 minutes, and activate the function. If the lights are set to turn off at 20 o'clock, they will begin dimming at 1950, gradually decreasing in brightness, until they turn off completely at 20 o'clock. 5. The programmable socket functions. Return to the submenu Settings and select Exit 1. Exits 1 and 2 can be switched, and have a built-in 10 amperes variable phase controller. Exits 3 and 4 function as simple, on-off switches. Go to the Intake Air Fan 1 menu and select the button, if you want to connect an AC intake air fan. Return to the Exit 1 menu, where you will see the activated function highlighted with a green frame. Go to the Exhaust Air Fan 1 menu and repeat the same process, if you want to connect an exhaust air fan to Exit 1. Go to the Manual button, activate the function manually, then navigate to the Condition Settings, and select either Manual on or off. Go to the CO₂, Temperature, Humidity, and Light sensor for gas. Select the button to activate the sensor on Exit 1, then choose one of the available functions, Heat, Cool, Humidify, or Dehumidify. For heating, activate the function using the button, set the desired day and night temperature, and configure the hysteresis values. Repeat the same process for cooling, set the desired day and night temperature, and configure the hysteresis values. Humidifying or dehumidifying, based on how you want Exit 1 to operate. Go to the temperature sensor for liquids. Select the button to activate the sensor on Exit 1, and apply the same heat or cool settings for Exit 1. Go to the timer's settings. Select the button to activate the timer function. Then go to Step 1 and set your start and end time. The start time includes hours and minutes, while the end time includes hours, minutes, and seconds. Activate the cycle using the button. The timer allows programming of up to 24 steps. Go to the CO₂ electric valve menu and select the button to activate the CO₂ valve on Exit 1. Repeat the same settings for Exits 2, 3, and 4. 6. The device settings. Return to the sub-menu and go to the device settings. Select Date and Time settings. Then set the current day and time. Navigate to the day counter setting, which increases by 1 every day at 0:01 o'clock. This counter is displayed on main screen 1, along with the current day-night status and time. Return to the device and select Photo Sensor settings. The controller automatically adjusts settings based on the day-night cycle you previously configured. The light sensor determines when day and night alternate. At the top, you will see the current light sensor measurement, displayed as a reference. Choose the desired level of alternation. If it's set to 30% light, then the controller will switch settings when the light is below 30%. Set the switch time setting. The switching time is a time delay, which starts a countdown, after reaching the light sensor level. This delay is for preventing immediate switching, due to brief exposure to light, such as when opening a door. Return to Device Settings and select Screen Settings. Choose whether the screen should be always on, not recommended, or set to automatic mode. Adjust the screen brightness and define the screen timeout, which determines how long the display remains on, after your last interaction with the knob. Before turning off, the screen will enter dark mode for 10 seconds. Return to Device Settings and select Alerts Event Settings. Choose a sensor value to monitor, temperature 1, humidity, CO₂, or temperature 2. Set a minimum or maximum threshold. If the sensor reading exceeds or falls below this limit, an alert will appear on the screen. To clear the alert, press the knob. If the issue persists, a red frame will be displayed around the screen. If you are using the GSE smartphone app in combination with the CO₂ controller, you will receive a push notification immediately. Return to Device Settings and select Sensor Offset. This function allows you to manually adjust sensor readings by adding or subtracting values from the original measurements. This does not calibrate the sensors but modifies displayed readings. Return to Device Settings and select Signal Mode. Choose the type of data signal, analog 0 to 10 volts, or digital PWM, pulse width modulation. For intake and exhaust fans, set the lowest possible RPM at which the fan starts spinning. This will be displayed as 1% speed on main screen too. Ensure the fan does not stall or fail to start at 1%, as the optimal value may vary depending on the fan model and manufacturer. Return to Device Settings and select Reset Values and Settings. Reset only the min-max values. This function clears all minimum and maximum readings of the measured values from the main screen. Select Yes, and confirm the reset by selecting the approval mark in the green field. Go to Reset to Factory Settings. This option restores all settings to their original defaults. Selecting Yes will erase all user configurations. Confirm the reset by selecting the approval mark in the green field. Return to the device settings and select Wi-Fi settings. Use the switch on the top right side to activate or deactivate the Wi-Fi function and enable network connection. Consult with the GSE CO₂ Controller manual for a complete guide on network configuration.